In order to get the idea of limit, let us first understand the meaning of x tends to a. Meaning of x tends to a. In symbol, we write x arrow a for x tends to a. Let us put a value to a. For the time being, let us take a is equal to 1. Now let us draw a real line and select the point 1 on the real line. We know that to the right of 1, every point on the real line have value greater than 1. Every point has value greater than 1. Similarly, on the left hand side of 1, every point on the real line has value less than 1. Now let us consider a set of sequence of numbers such as 1.1, 1.01, 1.001, 1.0001 and so on. Now the first point 1.1 lies on the right hand side of 1 on the real line. Let this be the point x whose value be 1.1. Similarly, the second point also lies on the right hand side of 1. If this is the point x, then this value may be 1.01. Similarly, we have a unique point for the third number 1.001, and similarly a point for the next number 1.0001. Here what we see, if we join more zeros after the decimal point, the distance of the point from the number 1 decreases. For the point 1.1, it is this much distance far from 1. Now if we adjoin 1 0 after the decimal point, then the distance of the point from 1 now reduces. Now if again we add 1 0 after the decimal point, then the distance of the point from 1 again reduces. So what we see, if we join more zeros after the decimal point, the point comes closer and closer to 1. If this is the situation, then we say that the point x is tending to a, or x is approaching 1, or x tends to, or x approaches 1. So we write x approaches 1. But every number x here is on the right hand side of 1. So we say x approaches 1 from right. And in symbol, we write x arrow 1 plus. 1 plus means approaching 1, approaching to 1 from the right hand side. Now again let us consider another set of sequence of numbers such as 0.9, 0.99, 0.999 and so on. Now if we consider the first number 0.9, which is less than 1, so it should lie on the left hand side of 1. Let this be the point x whose value be 0.9. Now for the second point, there is a point on the real line whose value is 0.99. And similarly for the third point, we have for third number we have a point x on the real line whose value is 0.999 and so on. So what we see here, if we join more 9s after the decimal point, the distance of the point from 1 decreases. For the point 0.9, the distance of the point from 1 is this much distance. Now if we add 1 9 after decimal point, then the distance of the point from 1 now reduces. Now if we again join 1 0, 1 9 after decimal point, then the distance of the point from 1 again reduces. So what we see, if we join more 9s after the decimal point, the point comes closer and closer to 1. If this is the situation, then we say that x is getting closer to 1, that is x is tending to 1, or x approaches 1. But every value of x here lie to the left hand side of 1. So we say x is approaching 1 from the left hand side. So we write x approaches 1 from left, and in symbol we write x arrow 1 minus. 1 minus means is approaching to 1 from the left hand side. So what we see here is that we can make x closer to 1 either from the left hand side or from the right hand side, either by joining more zeros after the decimal point or by adjoining more 9s after the decimal point. But what we see here, that by joining any number of 9s or joining any number of zeros, x is never equal to 1. So this is the meaning of x approaches 1. The meaning is that we can make x as closer as we wish to, as closer to 1 as we wish, either from the left hand side or from the right hand side by joining zeros or 9s after the decimal point. But in all cases, x is never equal to 1. So we write the meaning of x tends to a, x tends to 1 is x can be made as near to 1 as we wish or as we like, either from the left of 1 or from the right of 1. But in all cases, x is never equal to 1. This is the meaning of x approaches 1 or x tends to 1. Now we can generalize this to explain the meaning of x tends to a. So the meaning of x tends to a is that we can make x as closer to a as we like, but in all cases x is never equal to a. So we can write x can be made as near to a as we wish or as we like, either from left of a or from the right of a, but x is never equal to a. Geometrically, we can present it as, in the real line, this is the number a. Now we can make x as closer to a as we like, either from the left hand side of a or from the right hand side of a. But in all cases, x is never equal to a. So this geometrically means that x is approaching a or x approaches a, and symbolically we write x tends to a, that is x arrow a.